Are you ready to see some vintage technology?
This week, I headed out to work on a transmitter. This typically isn't something to tell my audience about, but today's a special case. The vast majority of new transmitters designed and sold on the market today use solid-state or transistor-based power amplifiers. These amplifiers are very reliable, but on their own, they can't handle much power. That's why solid-state transmitters like this Nautel GV series run a number of amplifier modules in parallel and feed them all into a combiner before sending the signal up the tower.
Before the invention of the transistor in 1947, nearly all amplification circuits used thermionic valves, or what we in North America call vacuum tubes. Radio receivers, hi-fi audio equipment, and computers have been using transistors since the late 1950s, but the amount of power typically used in broadcasting meant it took longer for solid-state power electronics to reach a stage where we could really take it seriously. As a result, tube-based transmitters were still being sold into the 2010s. A lot of them are still in service,
and we have two of them. Both are Harris HPX transmitters kept as cold spare backups. This one has a failing tube and can't run at more than about 80% of its configured power output, so today we're swapping in a new tube. Before we begin, we need to give the transmitter a once-over to make sure everything is in working order. We thought our day was derailed at the very beginning because we forgot that the HPX doesn't power up the exciter until the tube's filament is on.
We normally run our exciters on a UPS and power them all the time because newer HD-capable exciters take a while to boot up if the power fails. The transfer time between utility and generator would keep us off the air for much longer than the alternative. Older analog-only exciters, like the Harris Digit CD and our HPX transmitters, don't have this issue.
We ran the transmitter into the dummy load for a few minutes to make sure nothing else was wrong. Then it was time to get to work. The tube in these transmitters lives in a cavity accessed from the rear of the cabinet. The entire outer shell is one of the terminal contacts of the tube, and so it has this chimney clamped onto it. Air is forced through this cavity from the bottom for cooling. After cleaning some dust from around the socket and lifting the 9 kilogram or 20 pound tube into place, it's time to clamp the chimney back on and start performance tuning the transmitter for the new tube.
That was the easy part, but the real fun is in tuning the transmitter, which is a great topic for a part 2. Follow for more broadcasting content.